Our first presentation of looking at complex number operations ended with this slide, which was the example of converting 4 plus 4i into polar form. Let's now transform this to rectangular form and check our result. We have 4 radical 2 times cosine pi over 4 plus I sine pi over 4. We'll distribute 4 radical 2 through the parentheses. We need to find the values of the cosine of pi over 4 and the sine pi over 4. You should recall that this is square root of 2 over 2. Multiplying, we obtain z equals 4 plus 4i, or the original complex number we started with. If you want to try this on your own, look at number 30 on page 696. So now you might be asking, why did we spend time creating the polar form of a complex number? The following slides will answer that question for you. Let's investigate the multiplication of complex numbers in polar form. You previously learned to multiply complex numbers in standard form. But let's look at two complex numbers that are now written in polar form. So we have z1 with its modulus and argument and z2 with its modulus and argument. In class, we will be able to show that when you multiply two complex numbers in polar form, the result is you multiply the moduli and you add the arguments. So you multiply r1 times r2 and then just add the angles. Very easy. Let's look at an example. So z1 will be 6 with an argument of 40. z2 has modulus 5 and arguments of 20. We multiply. Well, do we need to do all this? Really, no. We can just say it's the multiply the moduli, add the angles, and we have 30 times cos 60 plus I sine 60 degrees. If you wish, try number 38 on page 696. We'll now look at the graphical representation of multiplication. Here's the graphical representation of z1. There's the graphical representation of z2. We multiply the arguments, the moduli. We add the arguments. In the dashed red line is the result of z1 times z2. Here we'll use some real values to look at multiplication of complex numbers. z1, which we'll represent here. And we're going to use the conjugate for z2. This will have an interesting result, as you'll see. The green represents z2. What do you notice about the two arguments? Think about that for a moment. Find z1, z2 graphically. Well, we have to multiply the moduli. In this case, each one is radical 18. So r1 times r2 is 18. We add the angles. Well, theta 1 is the opposite of theta 2, so that becomes 0. And I want you to notice that when you multiply the conjugates graphically, we end up with just the real number, just as we do when we do this algebraically. We will continue with division of complex numbers in polar form in the next video presentation.